All right, our video on segment lengths of intersecting chords, secant, and tangents. There are three different types based on the type of intersection and the type of lines that they give us. So type 1 is just two chords or secants that cross on the interior. So this would be type 1. And I'll go over the two type 1 equations right here. So the formula says just stay on the line, and then when you cross over cross the other line, you multiply. So A, I'm crossing over the line, times B. So A times whatever's over here, and then C times whatever's over here. So your equation for the first type here is just going to be 24 times x plus 7. So it's just going to be a distributive property on this problem. 24 times x plus 7. And then 27 times x plus 5. So you would just distribute and solve, and you'd have x there. Same thing here. I like to put the whole number first, so it'd be 18. From S to R, it'd be 18 over R times 2x minus 5. So it'd be another distributive property. Equals 14 times 2x plus 1. So there is type 1. There's your two examples of type 1. Type 2 is if you have that angle outside, you have two secants. That outside portion would be A, and that inside portion would be B. The math is you take your A, put it in front of parentheses to distribute whatever A plus B is. On the other side of the equal sign, C in front of parentheses to distribute the sum of these two. So let's look at type 2. All right, so it would be on one side of the equation, it would be 8 in front of parentheses times, well, this one we don't have to distribute, we just take 8 plus 19 equals 9, put your outside number in front of parentheses, and then add the 2, so it'd be 9 plus x or x plus 9. I like to put the variable first. On your second type 2, the top here section, I'm going to put 10 in front of parentheses, and then it'd be 10 plus 42 in parentheses, inside the parentheses. So that would be that equation. The next one would be 13, and then add x plus 13. So there's your equation for that second type 2. Here's your third type 2. You would say 8, open parentheses. I'm just going to say 8 plus 3x plus 4. That would be your first set. This is going to be a lengthy equation. Equals 7 inside parentheses, 7 plus the 5x plus 2. Is this how I would do the math? No, but I'm just trying to show you right in detail. So I would go ahead and just say 8 times 3x plus 12 and 7 times 5x plus 9. Okay, the next one would be 12. I'll do some combining like terms here. 12 times x plus 20, x plus 20 equals 15 in front of x plus 14. I'm combining the 15 and the negative 1. So there's your equations on the second type. Third type is this tangent out here you're going to square. So it'd be a times a, and then this one would be the exact same thing from type 2. B in front of parentheses, b plus c. Okay, so this first one of type 3, I'm just going to say 24 times 24. So that is my square of the first one, and then 18 in front of x plus 18. Okay, on this one, I'll do 16 squared. I'll go ahead and write that as 256. Let me do that in my calculator and make sure I'm not having any brain farts this morning. Yep, 256 equals 8. 5x minus 1 plus 8 would be 5x plus 7. So there's your equation for that one. Number 11, we are going to have x squared. So x times x equals 27 times the sum of 27 plus 21. So let me do that on my calculator. So let's see. Times 27. So I get x squared equals 1296. And then I'm going to take the square root of 1296 to solve it. And your answer here is 36. So I went ahead and solved that one for you. All right, on this one, I'm going to have 3x squared. So 3x times 3x is going to be 9x squared. That's what 3x times 3x looks like. Double the 3, double the x. 3 times 3 is 9, x times x is x squared. Okay? Now I'm going to take 9 times 25. 9 times 25, I get 225. All right, so I'm going to divide by 9. So I'm going to get this x squared by itself, divide by 9. That's how you'd solve that. And then take the square root to finish her off. And we are done. That answer would be 5. So there is your video on how to set up using segment length. The 3 segment length formulas to find variables on segment lengths for type 1, 2, and 3 of intersecting chords, secants, and tangents.